Hello, class. Continuing on section 7.4, the central limit theorem via proportions. We are now going to show you how to use the central limit theorem to do some approximate calculations of probabilities. And so let's go through a couple examples, and then I'll do one Alex problem as well. So let's see here. The book has a couple good ones. So, and this one I really like. And so why I like this is when I was in college, I worked at Baskin-Robbins. And so ice cream is near and dear to my heart. And so it says, according to a Harris poll, chocolate is the favorite ice cream flavor of 27% of Americans. If a sample of 100 Americans is taken, what is the probability that the sample proportion, again, if you think about that proportion being the mean, of those prefer chocolate is greater than 30%. And so you can see up here on the slide, we have indicated that we first want to make sure that our rule of thumb, figure of merit idea is greater than 10. And you can see that we've done that. And with 100 samples, that's a pretty good number, right? And so you'd have to have a proportion of less than 0.1 where you'd start getting less than 10. And so you can see those two numbers are both greater than 10, 27 and 73. So what I would like to do is to show you how I would do the calculation using the spreadsheet. And I'm going to do all the calculations on the spreadsheet. But you could see down here on the slide that we've done the mean and we've done the standard deviation, excuse me, with regard to that as well. So if we go up to the spreadsheet, and what is it? We're going to prove that the probability is greater than 0.3. So X is greater than 0.3. Okay, so let's go back. Let's go to the spreadsheet, and I've kind of got it set up. And so these are the three values that you need. And so you're given this one. This is 0.27. And our n value in this case was 100, right? Just double check that. Yep, and it's 100. And so what we ultimately want to calculate is the probability of X being greater than 0.03. And when you do greater than, need to hit shift. Remember that equals 1 minus the probability of X less than 0.3. And so either on your calculator or on the spreadsheet, you always get less than. So what do we need here? Well, we need the standard deviation calculation here. Again, you could do that with your calculator, but I'm going to do it on the spreadsheet here. And so I need a couple parentheses here. What happened? There we go. So you would hit 0.27 into parentheses, and then multiply it by 1 minus 0.27, and then divide it by n, which is 100, and then you take the square root of 0.5. And you can see you get 0.4440. Oops. And here we have 0.44396. So you could see if we round, you would get 0.444, and then 6 brings the 9 up and brings the 3 up to a 4. So how do you do this calculation? Well, here we want to do equals 1 minus, and then you want to bring up our normal distribution again. And so that would be norm.dist. And so we have all these values in here. This would be 0.3. This would actually be the mean, which you could just click on it and it brings it right over, right? And then the standard deviation, you could just click on it and it brings it right over that cell. And then you would hit true. And when you do that calculation, 1 minus that would be just under 25%. And so when you go back to our slide here, you can see that if you use the calculator with the norm.cdf calculation, you would get the same thing. So like I said, we're just going to go through a couple. So let's go through one more. And here, this is interesting and appropriate in the sense that our election is November 3rd. So we have 60% of eligible voters in 2016 presidential election. If 88 eligible voters were polled, would it be unusual if less than half of them had voted? And so this is a weird one because this thing of unusual is a weird word. It should be unlikely, in my opinion, and that is less than or equal to 5%. So again, you could see here, we did the calculations for the rule of thumb and we're good, right? We're 52 and 35, which is both greater than 10. And so in this case, our n value is 88. Our p-value is 0.6. And the idea of this unusual is that the probability if less than half of them have voted. And so that would be the probability of them less of 0.5, right? Because if you think about half, what would that be proportion? Well, if you had 88 voters, right? Half of 88 would be 44. And so that's what we mean by half. And so when we do this calculation, we're going to use probability of the proportion being less than 0.5. So let's do that again on the spreadsheet. You can can these. And this would be the probability of X being less than 0.5. And so here we have 0.6. Here we have 88. And again, to do the standard deviation calculation, it's 0.6. And then times 1 minus 0.6. And then you want to divide by n, which is 88. And then you take the square root. So it would be shift 6, 0.5 is square root, and you get 0.5222. And you can see, go back to the calculator, you would get the exact same thing. So finally, pull up the norm.dist. Here we don't have to subtract 1 because it's less than. So our x value here is 0.5. Our mean here is 0.6. Our standard deviation, I'll just click on that cell. And here we have true. And so you could see that it's 0.02776, which is 2.7%, which is less than 5%. So you would consider this to be unusual because it's less than 5%. My word would be unlikely. I won't ask you a goofy question using unusual on a quiz or an exam. But again, I could ask you the question, is the probability less than 5%? And then you could do the exact same calculation. So with that, that ends the walking through some examples via the book. And what I will do is jump on WebAssign, or not WebAssign, different class. Alex, right? Is it Alex? Yeah, it's Alex, and do a problem for you. And so let's do this one here. This is problem 4. Let's do problem 4. I like that one better. And I did that one already. Well, let's do problem 4 again, and I'll show you how to do it on the spreadsheet. So here it doesn't ask you to do the rule of thumb calculation, but you could see that 600 objects is big, right? So if you do 600 times 0.6, that would be way more than 10. If I get my calculator out, that would be 360, so way more than 10. And then 1 minus 0.6 is 0.4. So 600.4 times is 240. So we're definitely in there. So with regards to this calculation, I want you to calculate the mean, which is 0.6, standard deviation, and then compute the probability of the mean being less than 0.58. So again, n is 600, and our p-value, which is mean, is 0.6. So again, if we go back to our calculator, oh wow, 0.6. This is 600. And so what is our standard deviation? So that would be equals, that would be 0.6 times 1 minus 0.6. And then you want to divide by n. You could just plop n in there if you want. And then you take it to shift 6. 0.5 is square root and the exponent. And you can see you get 2%. So standard deviation using this central limit there with that big of a sample size, which is nice, is 2%. So here you want to find the probability of our x value, which is our mean, being less than 0.58. So when you plop that in there, come up with norm.dist. And so here it's 0.58. The mean is 0.6. Standard deviation is 0.02. And then it is true. Plop that down there and you see it's almost 16%, 0.15866. So if you go back to our Alex, sorry about that, here we go, our Alex, it asks for round to 4 decimals, so that's 6, get round up to a 7, so it ends up being 0.1587. So that ends the 2 recorded lectures. This is the second one on the central limit theorem with proportions.